In this video, I will tell us how to deal with the problem 5 in homework 2. And this is EL6303 probability. And we have known the problem is that we have a Poisson process. And the probability of the number of customer arrivals in the time range of 0 to time t equals to k, and this is probability. We have the Poisson distribution, and it is this formulation, and we still have that supposed the probability that in 2 minutes at least one customer arrives equals to 0.3. And we have so we can have this formulation. The probability of in 2 minutes at least one customer arrives. This probably is 0.3, and from the property that we still have another equations is that 1 minus the probability of in 2 minutes no customers comes, and this is still equals to 0.3. And so we can have the result that in 2 minutes no customer arrives, and the probability is will be 0.7. So for the first question, we want to find the lambda. We can deal with this formulation. We have so this can be rewritten as the Poisson distribution. Is that for the number of customers arrives in the time range of 0 to 2, this is 0. So this probability is equals to 0.7. They are the same, and we can have that. So this equations is equals to 0, and so we can have the result. We can have that lambda equals to minus 9.7. So we can have lambda optimaxi equals to 0.178. So we have the lambda. And the second question, we want to find the probability that in 3 minutes no customer comes. So we can still write this probability into this formulation, that we want to know the number of customers. There is no customer arrive, so number of customers arrive in 0 to 3 equals to 0. So this probability is that we can apply all these figures into this equation. Minus and 0. Okay. So this is equals to E. So this is optimized equals to 0.586. And in the third question, we want to find the probability that in 10 minutes at least 2 customers will arrive. And in this question, we can have the opposite probability, that for in 10 minutes at least 2 customers, and it's equals to 1 minus in 10 minutes no customers. So this can be written that so this is in 10 minutes that the customer arrive is 0 or 1. So we can write the formulation like so we have two parts. The first part is no customer came, and the second is that there is one customer come. At most, here's at most. In 10 minutes, at most, one customer come. So we have two parts. And this is equal to. Okay, so from this equation, we have the result. And the result is 0.531. And the last question is that we want to find the probability that in 1 minute exactly one customer will arrive, and this is a simple one. Probably in 1 minute one customer arrive. This is the probability that the number of customers arrive in 0 to 1 equals to 1, and we can have the equations. So the result of this question is 0.149. So we can have we done all the problem 5, and we can know that for all the questions we only use this formulation, so it is very important for us.